disruption. So don't be a double disruption, please. Thank you. All right. Today we are going to use our understanding and knowledge of the ambiguous case to do certain things. We're going to determine the length of a chord in a circle. Do you even know what is a chord in a circle? You shall know. Using concepts of the ambiguous case. Secondly, we're going to solve problems that relate to ambiguous case. So in these questions, we are not going to solve both triangles, but we're going to use that concept to look at, to figure it out. And very often, folks, I'm going to show you which part of the triangle we're going to look at. So here we have an ambiguous case. This triangle is KN either to M or KN to L. So we know that this angle of L and this angle of M are supplementary angles. What do they add up to? 180. If they are supplementary, they are 180. Now, and how do I know? What's the first thing I can see here about triangle KNM that tells me it might be an ambiguous case? Yeah.
It's two sides and the angle.
Beautiful. And the angle is not contained, right? It is SS8. Beautiful. Now, this is the hint, folks. Listen up. In these word problems, most of the time, we're actually looking at this isosceles triangle. Okay? Most of the time in the word problems, we look at the length between the two angles. Do you hear me? Do you want me to say it again? All right. When we are solving word problems using the ambiguous case, most of the time what you're going to do is you're going to find the distance between the two angles of the ambiguous case, right? This obtuse angle and this acute angle. So it's the bottom of that isosceles triangle, it's the base. In most cases, that is all you're really solving for. So yes, you're gonna have to move. So yes, these questions are gonna be confusing, but if you're super confused, just remember that Miss Sly said, just find the distance find the length of the base of that isosceles triangle. Okay? All right. So let's look at this first question where we are talking about a chord. Now, a chord is defined as a line segment. You can recycle that. Thank you. A line segment that connects 2 points on the circumference of a circle. So this is a chord. This is a chord. Is this a chord? Like going right through the center? Yeah, that's also the diameter. So the diameter is a chord, but a chord does not have to be a diameter. A chord can be all different kinds of lengths. So a chord is basically any line that goes from one edge of the circle to another edge of the circle. Okay. Examine the following diagram and identify the quantities, relationships, and terms you may know. All right, so what do we know here? We know that we have an SSA situation. What else do we know? Yes. Great. So instead of saying it the middle line, what else can we call it in regards to the circle? No. It's not the diameter. It's the radius, right? So that middle line, the line that goes from the middle of the circle to the edge of the circle, is called the radius, right? And that means that any line that goes from N to the edge is going to be 18 centimeters long, right? All right. Now, why is 20 not 18? Well, that's because this is a point K that is outside the circle. And we use that. This is part of the information given to us so that we may solve for the isosceles triangle. Okay. Now, knowing the ambiguous case, which angle can we solve for first? Yeah. Okay. So we would solve for M first, right? So first we would solve for M. Whoa. Using which law? Good. What could we solve for then? Yeah. What name that angle? I'm not sure which angle you're talking about. Do you mean LNM? KNM. Sure, but what's the first thing I do that's easy? What is a quick thing that I do when I solve for M? Which angle is supplementary to angle M? Yeah, right. So, but I'm going to be specific. I'm going to call it KLN because there are two angle L's. Agreed? So I'm going to be specific and say, hey, I'm talking about this angle. That angle is going to equal to 180 subtract angle M. And let's write that down. They are supplementary angles. Okay, now I told you that these word problems are all about finding the length of LM. And sometimes when we are solving for the length of a line segment, we draw a line on top of the two vertices, right? How can I solve for LM, right? Because I know they're going to say, what is the length of the chord? So I have a few steps. What step? First of all, I need to find, so if I have this triangle, so that's what I want to solve for. Okay, well, let's draw this little diagram and label what you know about this triangle, because we actually know quite a bit. Mm-hmm. Yes, and I just realized I wrote L twice. Yes, so what I said when you weren't listening, when you were chatting, so just turn around and be like, I can't believe you did that to me.
Well, I'm so sorry for asking you a question, Liam.
All right. All right. So watch this. Okay, and I imagine other people missed this. So look here. LM is the line joining the vertices LF. A line on top, Annabelle, does it just mean the line or does it mean the length of it? I'm blanking here. Just the line. Yeah. So instead of saying, like, we use the angle sign for angle, if you put LM with a line, that just means we're talking about the line. All right. So in this triangle, I know that the two sides are 18 centimeters long. I know angle M because I solved for it. I'm just going to put an M here. Which other angle do I know right away? Yeah, Mustafa. Beautiful. Right? Now, if two angles are identical, all we do is we give them the same number of half circles, right? So we can do 2, and that means these angles are identical. Okay, so I know angle L equals angle M. How about angle N? Can I solve for that one? Yeah, which law do I use? The sum of angles, right? We need to know that word. 180 minus L minus angle M. I have almost solved the triangle. There's literally one piece I need to find, and that's the one piece I'm looking for. Yes.
These types of questions, are we only going to get like isosceles triangles?
Well, that's the definition of an ambiguous case. Is the triangle that is formed as a result of the ambiguous case is always isosceles, right? Now, keep in mind, this triangle is not isosceles, right? So you do have to check, am I working within the isosceles triangle? Okay. All right. And then can I find the length, LM? Absolutely. Which law should I use? Yeah, great. Yeah, because it's easier, right? Could I use cosine? I could, right? But it's because I have all the information. Find LM using sine law. And this is the length of the chord. So in this question, one moment. In this question, the new knowledge is really understanding um, what is a chord, and then how do we apply the ambiguous case to this. Yes.
Why did we solve for angle KLM? We don't use that anywhere else.
That's correct. We didn't need to. I was just sort of listing like, hey, what do we know? What can we easily find? But if we were looking for the length of the chord, that's right. We don't need this angle to find the length. All right. Okay, so I'm not gonna. We've listed the steps. Maybe let's say this step is not necessary. So yeah, step 2. I'm gonna call it step 2. Not necessary to find the length of the chord. All right. So now that we have talked about the steps to finding the length of the chord, let's actually do that. Do people need more time to copy? All right. So here we have a question. The question. Okay. And let's do a quick check for ambiguous case. Even though I know this is an ambiguous case because that is what this lesson is about, let's review how to check for ambiguous case. Step 1 was, is it an SSA triangle? Yep. All right, let's have everyone do the check on their own. If you need to, go back and look at what those steps are. And also now we have KLM as opposed to ABC.
this one.
Yes.
Is M like an A?
Is N an A? No. So watch this. Let's go back to the. So let's think about which one is the A and which one is the C. So in these triangles, the A that we talk about is across from the given angle. So in this case, which letter is the A? In our question on here, it's K, right? Because it's across from the 60 degrees, okay? And then the other line that we compare it to is the other side that is given. We can't use the bottom because we know nothing about it. So what is the C? Is it the L or the N or M? No, not the L. Which letter is going to represent the A? Sorry, the A, the C. Yeah, you can. No, it's M, or you could call it KN, right? But we're gonna just call it M because it's across from there. So, and what's tricky is usually we don't have both L and M's. It's usually M1, M2. Okay, so let's label this line as M. Sorry, other way around. This one is our K. This one is our M. And let's check, does it work? So the next check for ambiguous case is that K has to be greater than or less than M. It's got to be less than M. Is it? Yes, it is. Then we had the other one, that K has to be greater than M sine which angle? Yeah, and it's really the only one we have. So is it? So we have 20 times sine of 60. What does that give me, Luke? Perfect. So that means yes, K, which is 18, is greater than 17.32. And lastly, we look at the angle that is given, which is angle K, and we check, is it acute? Is it less than 90 degrees? Yes, it is. Great. All right, we thought it was going to be an ambiguous case, and now we see it truly is. So that was our check. It is ambiguous case. And so the point of this question, we need to solve for the length of LM. What's step one? Well, yeah, we said let's solve for angle M using sine law. Okay, so we're working. So I might say it like this. In triangle KNM, right? So that we know which triangle we're working in. So in triangle KNM, I'm going to say K over sine K equals M over sine M. Okay, sub in the numbers, solve for it. And if it's a bit confusing, you might want to draw which one is K and M. I know that's 60. I know this is 20. This is my N. This is 18. This is M. K is 18. M is 20. And angle K is 60. Oh yeah, I can use that good old T rule. 20 times sine 60 divided by 18. And I'll get something like 0 point something something, and I won't worry because that is just giving me the ratio. And then I must take the inverse sine. So folks, this is a case. This step is where I use my ANS button, right? I'm going to get some kind of answer. I'm just going to say ANS, right? And then I can find angle M by taking the sine inverse of whatever my answer was. Okay. And were we told? We weren't told. So I'm going to leave it to one decimal place. I got 74.2 degrees approximately. Okay, what was step 2? Let's check. Step 2 here was we were looking for the obtuse angle, but we said we don't need to do that to solve. So we're skipping to step 3 where we find LM. Okay. So now our next step is, okay, well, if I know that angle, so now we're changing triangles. Now we're in triangle LNM. We're in the isosceles triangle. (74.2), and that means that angle L is the same, 74.2. Right, we can even say angle L equals angle M. And then we can find angle N. Now, folks, notice I didn't call it LNM, and I don't need to because I've already stated that I'm working in this triangle. So if you state which triangle you're working in, you can just use one letter for each angle. All right, so let's solve for angle N. That's going to be 180 minus twice 74.2. Okay, and I get the angle N is approximately 31.6 degrees. Are we following? Are we good? All right, last step. We're looking for the length of the chord. So let's find N, right? N, or another way, AKA LM. You can put a line on top. You don't have to. And once again, we're going to use sine law. No worries. I got sine of N, 31.6 over N equals, and here I'm going to be a bit lazy, both sides, because it's isosceles, I'm working, it doesn't matter which of the pairs I choose. Right? It doesn't matter which pair, so I'm just going to jump right in without the formula. Multiply, divide. Let's give it one decimal place. We're using the approximate equal sign really nicely. I got 9.8. Did other people get 9.8? Okay, try not. Yeah. And I didn't state, but you always want to err on the side of caution and keep a bit more information. All right, before we move on, just because we all said it, we got the same answer doesn't mean we're right. So let's just quickly look at our triangle and say, does it make sense that this side is 9.8? Why, Lily?
It's across from the smallest angle as well.
Beautiful. It's across from the smallest angle. As such, it must be shorter than the other two sides. Beautiful. And notice that it's roughly proportional. So 74 is roughly twice as big as 31.6, like just roughly, right? But notice that 9.8 is roughly half of 18. Okay, definitely not fully proportional, but there is some connection. Okay, so if I instead got like 17 across here, I can't just say, oh, it's smaller. I know it has to be significantly smaller. All right, so folks, we found the length of a chord. Okay, let's try another question. I want you to read this question and read it twice or 3 times. Anyone a bit confused? This is a bit of a confusing question. So I'm going to start adding pictures to it. Okay. The light from a rotating offshore beacon. Do we know what a beacon is? Like basically a light, and it's a light that rotates so that ships can see it. They're like, this is where land is. Do not go here. Okay. Kind of like a lighthouse, except that this beacon is offshore. It's in the water. Ми тут говоримо про світло посередині води. Це не є як маяк. Це у воді. І воно тут це та вежа, і вона світить. And that light that it sends out goes as far as 250 meters. So watch this. I'm going to show you this light. So how do I? Nope, that's square. Oops. All right. Whoa. I think so. All right. So here is the light. This is the circle that the light will create. Okay. Who's able to see what's happening here? Okay. Here is the shoreline. Okay. So this is shore. This is water. Maybe we want to add that to the picture. This is water. This here is land. Okay. Shoreline just means, oh, that's like a beach. Okay. Here is water. Ships are here. Okay. Canoes. And in the nighttime, when the ships are traveling, they want to make sure they don't hit the shore. And so, as such, you have this beacon that goes, I don't know, it's maybe like 150 meters into the water. And it just makes a circle. It's like, woo, 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 woo. Actually, I can be even better than that. This is what it does. It shines a light. All right. And so what it's saying is that the distance that light will reach is 250 meters. That is also what about the circle? Yeah. Radius. Beautiful. So what we just found out, and for now, I will just draw it here, that the radius here equals 250 meters. We good? And this yellow is, maybe I should label it, light from beacon. Okay, next. A point on the shore is 500 meters straight from the beacon. This is the point. Okay, maybe we're standing there. We're on the shore. We're looking at the beacon. We're like, wow, you're a really nice beacon. Okay, and when we measure, so this is the line of sight to the beacon, and when we measure, the angle between our line of sight and the shoreline makes 20 degrees with the shoreline. Now, this is the question. What length of the shoreline is effectively illuminated by the beacon? Okay, so look at this picture. We are asking, what distance, what length of the shore will be illuminated? When they say effectively, they're saying that the light effectively shines 250 meters because it doesn't just stop. It's just that afterwards it's too dark. So have I drawn that length already? Yeah, what else? What did we call it earlier today? A chord. Oh my gosh, look. Here is that length. Right? It's just a chord. Yes. This silly, super complicated, wordy question is just saying find the length of a chord. Not a big deal, right? We knew that. All right. So can I now draw a triangle that will resemble the ambiguous case and allow us to find the length of the illuminated shoreline? Well, yes, I can. I will connect from the beacon to the two edges of the shoreline, right? And so we're saying that this, if you need to, we can label that this is the illuminated shoreline. All right. Now, folks, do we know how to solve this? Yeah. So let's give it some letters, and then I'm going to have you solve it and answer questions. So let's redraw this triangle to make it a bit cleaner. I'm going to call it B for beacon, P for point. This is 20 degrees. And I'm going to call this S1. No, let's just call it S. And let's be creative, X. Okay, so what do we know? Well, we know this is an isosceles triangle. What is the distance between B and S? Yeah. And we know one more distance. We know that this is 500 meters. I want you to try to solve for that distance. Okay, if you're not sure what to do, use the steps in the last question. Okay. And you're solving for the height of the pole. Okay, it's a tricky one. Yes. Yes, definitely. But I haven't started marking, but I definitely intend to see you before. Maybe until tomorrow. I'm trying to think. Other questions? Patrick, do you have questions? Okay, Ben, you got questions? Okay, Victoria, do you have questions? Okay, дивися. Сонце, ти переклала це? Ти ще не переклала. На 5. Дивися, тут моя, так, тут світло. Тут ми стоїмо, бачимо маяк, і це 20 градусів між землею і водою. Окей? І каже, що це пускає світло на 250 метрів ефективно. Добре? То ми кажемо, окей, яка довжинь берега буде освічена? Точно. Anyone need help solving? Okay, I think the tricky part is figuring out the picture. I'm going to slowly work here. You can see what I do here. I'm going to start. Step 1, we're going to start in the big triangle. P in triangle PBS. And I'm going to solve for angle S. Absolutely. Just go. Yeah. As I'm writing here, please feel free to ask questions. And so, folks, if you want, like, watch here. I'm going to skip a bunch of steps. I'm not going to write all that stuff out. I'm just going to figure out what S is. What did they tell us? To the near, okay, watch this. So if the question says to the nearest meter, keep one extra decimal at least, okay? So that means I've got 43.2 degrees approximately. That's all I need to do in the big triangle. Now we move over to the smaller triangle. In triangle XBS. If I want, I can redraw it. I know this is 43. I can say angle X equals angle S equals 43.2 degrees approximately. Then we find the other angle B. Right, and I wrote 2 times 43.2 because there are 2 identical angles. Yeah, yeah. Okay, and I get the angle B is quite big, 93.6 degrees approximately. So I'm looking for quite a long length of the shore. Okay, lastly, I'm going to find that length. All right, I'm going to call B the length of the shoreline. So I'm going to set up a sine law. Folks, notice I write the formula every single time. I don't need you doing that every single time, right? It's okay if you just pop the numbers in right away. Sine. Okay, and now we round to the nearest meter. Okay, I get a number that seems realistic, but I'm going to check my calculation again. Yeah. How many people are getting a hang of those steps that we take? Notice we're solving for the exact same side, right? And so then we did all this beautiful work. We're going to say, therefore, approximately 364 meters of shoreline is illuminated. Mm-hmm. Good question. Like, how did I know it was here? So, okay, so we have a beacon, and I think it's important to understand how a beacon works. So it's a rotating light. So it's like a light that goes like this. And so I knew there was going to be a circle around the beacon. And at some point, that circle was going to touch the shoreline twice. That kind of help? Well, it's got, if it's too small, then it won't touch. it doesn't, like, in the end, I don't, if you drew a smaller circle and had it touch here and here, that's fine. Your calculations will give you the same answer. But I agree, it is tricky to know how, and that's where doing the homework is going to be really helpful. Okay. And folks, I've had a moment of reflection, and I'm going to give everyone what they want. We will not start the next unit until Friday. Okay? Because I know this is tricky, but I also know you can do this. And so I want to take time to draw diagrams, to understand how to identify what we're solving for, right? So that you can really rock this test. Okay? All right. Let's look at the next question. We might not solve it, we might, but at least let's draw the picture. Okay, so read it 3 times, okay? All we're going to do today is draw the picture. We'll solve it tomorrow. Okay, we've got an island. This is a fun question. All right. Sebastian, what's your guess about this radio transmitter? What am I going to draw to show its symbol? A circle. Yeah. So if there's a radio, like I'm the radio, and I send out signals in every single direction. Okay. So what we're saying is this radio transmitter can send out a signal, need a big circle, in 12 kilometers each way, right? So I know that the radius, equals 12 kilometers. Okay, a circle, we've dealt with this before. And then the really fun part. One of the stranded individuals spots a ship approximately 15 kilometers away, traveling due south at a bearing of 314 from the transmitter. Oh boy, oh boy. All right. In order to do that, we need to place the compass rose around the radio. Right? That's north. And we remember that north is 0 degrees. That's south, and south is 180 degrees. Right? This question will never, this is northeast is 90 degrees, and west is 270 degrees. So a review. If we are told that the ship is, forget the due south for now. What we're told is the ship is at a bearing of 314. That means this. We start at 0 at north, and we're going to go clockwise. 90, 180, 270, and then a little bit more to get to 314. Okay? So that means so from 270 to 314 is going to be 30, 44. So about here. Okay, here is the boat. What do I know about it? Well, I know this boat is at a bearing of 314 degrees. What else do I know about how that boat is moving? Yeah,
It's going due south.
straight down. So if it's going due south, it means that this is the path of the boat. Path of boat. Do you see that? I know this is a lot. This is like a thinking inquiry question, basically, but I'm doing it with you guys now. Anyone see what we're going to be solving for? What is it called? The chord. Okay, so drawing the picture is tricky as heck, but then once we got it, we're like, oh, we're just solving for the chord. So we know that the length of the orange is 15 kilometers, and we are asked over what distance will the ship be in range of the transmitter. So what that means is between here and between here is the length of the transmitter. Okay, let's redraw this triangle so we could work with it. B for boat, R for radio, and then we'll call this X and Y. And I'll just label them X and Y on the picture so you can see what we're talking about. So we know that the radio sends out a signal that is 12 kilometers, right? So these two lengths are 12 kilometers. And we know that the boat is 15 kilometers from the radio. So that is okay. What's going to be tricky is figuring out angle B, right? We're going to have to use some of our knowledge of trigonometry. Find angle B. So if I look at the west direction, and here is my north direction, how much left over? So what I want to find out is this little angle, 90, 180, 270. How much is left here? I got 30 plus, I got 44 degrees right here. This is 44 degrees. This is a 90-degree angle, and as such, what is angle B? Is going to be 180 minus 90 minus 44, and that is 46 degrees. I feel like that was a whopper of a lesson. Yeah.
Could you also use like the zero for parallel lines if you found the remainder of the 360 degrees, and then just use parallel?
Yes. Yes. Yeah. So Val is saying, okay, instead of finding this 44, can I instead say, well, how much between 360 and 314? How much is left over? It's 46. And then say, boom, 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 the parallel line theorem. These two are the same angle. Absolutely. Love it. Okay, so folks, this was a big whopper of a lesson. I know people are behind on homework. Okay, I have given you a bit of a gift of time. Please use that gift wisely. If you are really stuck on this question, the visualizing part, then practice, look at the homework questions and just practice drawing them. Okay, and tomorrow what I'm going to do with you is we are going to practice drawing pictures on the boards because I know that's the hardest part of this trig unit. Okay, we'll start off tomorrow by solving this just as a way to review the steps. Okay? Good job.